This is not really a new topic. It's just an extension of a bunch of stuff we've already done. We're going to look at solving nonlinear systems. So just to set this up real quick, think what it means to solve a system of any kind. If I've got a system of two equations in two variables, x's and y's, you remember doing stuff like this. What did our solutions look like? When we solved linear systems, it was the point of intersection of the two lines in the system, right? And we even looked at like a 3x3 linear system was going to be the point of intersection of the three planes, right? So we're not looking at anything that weird, but we're just looking at finding the intersections of two functions, at least one of which is nonlinear. Okay, so in this case, I've got this bottom equation that is a line. If I graph that, it's a line, and the top equation is not. So the only thing that's different about this compared to what we did earlier in the year, when I'm finding solutions of nonlinear systems, they might have more than one intersection, right? Like if we look at what this guy looks like, look at a graph of this, and we're just trying to find points of intersection, right? At least that's what graphically what it represents. Well, there's the bottom line. Okay, if I graph the bottom equation, it's a line. The top one is a parabola, and look what happens. I end up getting 2 points of intersection this time instead of one. I get a point of intersection at 5, 1 and a point of intersection at 7, 4. And it's worth remembering that that bottom equation on its own has an infinite number of solutions. There are an infinite number of values of x and y that would work, that would make that equation true. And here's some examples. Look at all those ordered pairs. As I drag this point along the line, these are just a few of the infinite possibilities, right? There are an infinite number of points that would come together to make that line. Each of them has its own ordered pair corresponding to its position. The same thing is true for this parabola. There are an infinite number of ordered pairs corresponding to points on the parabola. But there are only two that simultaneously work for both at the same time. And so those are the solutions of the system, right? The values of x and y that simultaneously make both of the equations true at the same time. So our goal today is to find those ordered pairs without using Desmos. So how could we do this? Let's think back to what we did with linear systems. We had two different strategies, and we used both of them depending on which one was easier. We could substitute, right? We could solve for a variable and substitute into the other equation. Sometimes that was really easy to do. And then the other one we had was elimination, right? Remember what the goal of that was to try to manipulate the equations so that when I add them up, either the x term or the y term canceled out, leaving me with only a single variable to deal with, which is good, right? So what about this guy? Which of those two techniques, and by the way, those apply with nonlinear systems too. The same two strategies are what we're going to rely on. So which of those two seems easiest here? Substitution, for sure. Look, I've already got an equation that's just, handed to me where y is by itself. It's already ready to substitute, because that's what I need to do when I want to substitute. I have to solve for one variable in one of the equations and substitute into the other equation. So here I've got my y. I'm just going to plug that into the y in the bottom equation, and we're good. So what's that give me if I do that? So my bottom equation is going to become 3x minus 2 times y, but we're trading the y for a 1/4 times the quantity x minus 3 squared, right? Equals 13. Okay, good. I don't really need those outer parentheses, do I? I could get rid of those. And I could just replace those with a multiplication sign. So there's a single equation. I've got only x's in that equation. So theoretically, if I have only one variable in an equation, I should be able to solve for that variable. Now, sometimes in math, that's hard to do. Sometimes it's not such a big deal. Well, this time we're going to be able to do it. We can already kind of see that if I expand this whole thing out, aren't I just going to get a second degree polynomial? Right? Can you kind of see that? If I expand out the x minus 3 squared, that's just going to give me an x squared term and an x term and a constant. And I'm just going to distribute some number through to each of those. And so I'm just going to end up, after I do some cleanup here, some simplification, I'm just going to end up with a regular old polynomial equation. Okay, but let's get there. This is some good practice. So remember also that when we multiply a series of things together, we always multiply in pairs. Well, look here, I'm multiplying negative 2 times 1/4 times this whole quantity squared, right? So I'm going to multiply those things in pairs. Negative 2 times 1/4 is just negative 1/2, right? So my next step would be I've got 3x minus 1/2 times the quantity x minus 3 squared equals 13. Okay, now I can't distribute that negative 1/2 into this quantity yet because this is being squared, right? So when I'm simplifying this, I need to take care of the exponent, don't I? I need to expand that out. So there's my next step. Let's expand this whole thing out. This is just the pattern a plus b quantity squared, isn't it? Right? So what's that going to be then when I expand out x minus 3 quantity squared? What's that going to give me? So this whole thing is going to become what? X squared. So there's my a squared plus 2ab, right? So what's that going to be? Right? Because we have to do that whole pattern. We can't just square the first and the last. That's not how that works, remember. We've got to do the pattern. Let's just write it up here. How about a plus b quantity squared is what? What's my expansion pattern for that? You just got to know these. There you go. A squared plus 2ab plus b squared, right? So my a is like x and my b is like what? Negative 3. Everybody see that? So a plus b is replaced by x plus negative 3. Okay? So then what am I going to get for my a squared just turned into an x squared? What's my 2ab going to be? Two times x times negative 3. What's that? Negative 6x. Everybody give me thumbs. Does that make sense? Okay. So minus 6x and then plus b squared. Yeah, negative 3 squared is just 9, isn't it? So plus 9. Okay, so all that blue stuff gets expanded to that trinomial, right? And so now we've got 3x minus 1/2 times all that stuff equals 13. Okay, well, I could distribute the 1/2. That's no big deal. So I get 3x minus 1/2 times x squared is minus 1/2 x squared. Negative 1/2 times negative 6x, isn't that just plus 3x, right? And negative 1/2 times positive 9 is just minus 9/2, right? Equals 13. Any like terms I could easily combine there to make this a little smaller? Yeah, 3x and 3x gives me 6x, right? So we get negative 1/2 x squared plus 6x minus 9/2 equals 13. And we just did that, right? Okay, so we're getting there. That's looking more and more like a regular old quadratic equation that we could deal with. One thing that's a little bit annoying about that, though, is what? The fractions, yeah. It probably is worth our while here to clear those fractions so we don't have to deal with them all the way through. How could I clear the fractions? Yeah, good. I could just multiply. I could multiply by 2, but even multiplying by negative 2 is even better then, because then I'm going to be left with a positive coefficient of x squared. I want my leading term to be positive, don't I, when I'm solving equations? Yeah, so what if we just multiply the whole thing through by -2, if I distribute that to all the parts? Oops. What's that going to give me then? -2 times -1/2 is +1 x squared. -2 times +6x is -12x. -2 times -9/2 is +9. And -2 times +13 is -26. That's looking way better. Now we got a quadratic equation that's pretty easy to deal with. What do I always need to, what's my next step? What do I always need to do? Set equal to 0. Got to put it in standard form. So I'll add the 26 over to this side. And I get x squared minus 12x plus 35 equals 0. Quadratic equation in standard form. I can always rely on my ace in the hole and just use the quadratic formula, but it'd be quicker and easier if I could factor this. Are there magic numbers? What do they need to multiply to? 35, good, and add to -12. So what are they again? -7, -5, good. So what are my solutions then? 7. Okay, good. So either x equals 7 or x equals 5. So we done? 7 and 5? We good? We good to move on? Are we? We need ordered pairs. Yeah, don't we? We need y's also. So I need to get the y values. Well, I had two different x values. I had the x value x equals 7 or the x value x equals 5. We can try both of those, right? So what about x equals 7? I need to find the corresponding y value. Where would I go to find the y value? I could go into really either equation, couldn't I? I want to just know what y is when I plug 7 into either one of those equations. I can use either one because they both have to work, don't they? I'm trying to find the point that works on both of them. So whichever one looks easier. I think personally, I mean, really, either one would be fine. You know, maybe that top one is easier. We always use the bottom one because it's linear. But if I plug 7 in the top one, that's pretty easy too. 7 minus 3 is what? 4. Squared is 16, right? So I end up getting y equals 1/4 times 16. Y equals 4. Everybody agree? If I plug this guy into the top one. So I get the ordered pair, x equals 7, y equals 4, right? How about my other opportunity, or other option? I've got x equals 5. If I plug that into the top one, 5 minus 3 is 2. Squared is 4. Times 1/4? 1. So I also get the ordered pair 5, 1. And so this is my answer, right? In the computer, they're just going to want you to separate all your solutions with commas. There's two solutions, two ordered pairs. Okay? Give me 1 to 5. How are we doing? Okay? Good. Good, good. All right, let's try another one. How about that one? We're getting to a point now where it really pays to just pause and think about these things before you jump in. And the further you go in math, the more that pays off. When you get up to the level of calculus or advanced calculus, oftentimes there's many different directions to go, but one of those directions could be really tough and the other one might be a lot simpler. And so it really pays to think about this in advance. Which technique seems better here when you think about it a little bit? Substitution or elimination? Elimination definitely seems better, right? Substitution would be kind of tough. Solving for one of these variables would include taking square roots, so I'd get plus or minus square roots that I'd have to be plugging into some equation. I mean, that's going to be kind of a mess, isn't it, right? So we definitely want to use elimination. It'd be a little bit easier to eliminate y just because the coefficients are smaller. How could I do that? What's a number that I could multiply the top one by and a number I could multiply the bottom one by in order to make the y terms cancel? Yeah, 2 and 3, does that make sense? 2 in the top, 3 in the bottom. That's going to give me, when I distribute, it's going to give me a negative 6y squared in the top and a positive 6y squared in the bottom, and so those terms would cancel, right? Distributing a 2 all the way through the top is going to give me, what, 8x squared minus 6y squared equals negative 22. Distributing to 3 through the bottom gives me 15x squared plus 6y squared equals 114. Okay, and if I add those up, what's the good thing that happens again? The y's cancel, yeah. And when the y's cancel, that leaves me with an equation I can solve because it's only got a single variable in it. So 8x squared plus 15x squared is 23x squared. Negative 22 plus 114 is 92. Well, what are the 2 steps to solve for x there? In order. What do I got to do first? Got to divide first and then square root, right? So divide by 23, and that gives me x squared equals 4. So what are my solutions then? 2 and negative 2. Good, I get plus or minus 2. So we got to try both of those. So if we try x equals 2, my other option is x equals negative 2. If I try x equals 2, and let's just plug into the bottom one, how about? So if I plug 2 into the bottom equation, I'm going to get 20, right? 5 times 2 squared. So 20 plus 2y squared equals 38. What am I going to do? What am I doing next here? Gavin, what am I doing next? Got to solve for y. Subtract 20, good. So 2y squared equals 18. Then what? Divide by 2, good. So y squared is 9. And so then I'm getting what 2 solutions? 3 and negative 3, plus or minus 3. Okay, so look at that. That gives us 2 ordered pairs, doesn't it? When x is 2, there are 2 y possibilities. So what are my ordered pairs going to be? What's one of them? Ashley, give me the 2 ordered pairs I get from the blue math I did there. I took x equals 2, and that gave me 2 different y outcomes, right? When x is 2, y can equal plus or minus 3. So what's one ordered pair? X equals 2, y equals 3. There you go. There's one. What's another one? X equals 2, negative 3. Exactly. Anybody see that? Got 2. Okay, what about when x is negative 2? We got to try that one. So if I plug negative 2 into that top equation, what's 5 times negative 2 squared? 20. So I get 20 plus 2y squared equals 38. Does that look familiar? We've seen that before. That's the same equation that we solved in blue, isn't it? You suppose I'm going to get different solutions if I do it in green? No, I'm going to get the same solutions, aren't I? So without even repeating the work, I know that's going to give me y equals plus or minus 3. And so then what would my 2 ordered pairs be in green? Negative 2, 3, or negative 2, negative 3. So I end up with 4 solutions to this nonlinear system. Now, how can that be? How could that possibly be that I get 4? Well, if we had parabolas up there, What's the maximum number of intersections that two parabolas could ever have? What do you think? 2. Yeah, that's it. The most I could have with two parabolas is 2, but maybe these aren't parabolas, huh? Let's check it out. Murder mystery, yeah. Okay, is anybody, let's start with, how about the bottom equations? Anybody want to just make an educated guess about what that shape is going to be, or that shape, I mean, what's that function going to look like? In what shape will the function be? 5x squared plus 2y squared equals 38. Any ideas? It's kind of weird because it's got x squareds and y squareds in it, right? What's it going to be? No. No, it's not a quadratic function. It's good, but it's a non-function, I'll tell you that. It's not a function. It violates the vertical line test. I thought I heard circle? Well, it's close. It's an ellipse. Yeah. Yeah, it's like, that's our math word for an oval. There you go. Okay, it's an ellipse. What about the top one? What if I have an x squared term minus a y squared term? That's going to be something else we haven't seen yet. That's a hyperbola. Okay? And notice this does have 4 points of intersection. How about that? Okay? Yeah. Here, I'll take a picture of that for our notes. Okay? There we go. So we got it in our notes. Okay, moving on. Okay, this time, how about if we don't do the whole problem? Because once we get it set up, it's going to be something that you guys would be able to easily do. So what's our strategy going to be? That's the most important thing to resolve. What's our strategy going to be here? Are we going to use elimination or substitution here? Because there's a definite answer. Substitution for sure, right? There's really no way for me to use elimination because the x terms and the y terms are never going to be like terms. They'll never cancel, right? So we definitely would use substitution. And it'd be really easy in this case. I could solve for x by just adding y to both sides. So x would just equal y plus 2. And then all I would have to do is plug that x into the top equation. And isn't that just going to give me, instead of x squared, I'm just going to get the quantity y plus 2 squared plus y squared equals 202. Everybody good? And then I would just expand that out and combine like terms and solve the quadratic equation. Agreed? And you guys can all do that. We won't even take time and do that. Let's move on and look at another example. So what about this one? What's my strategy here? Am I going to do substitution or elimination? And again, there's a definite best answer. Elimination for sure. Because I want to cross out those weird x, y terms, don't I? Get rid of those. So we could just multiply. I could either multiply the bottom one by -1, or I could even just subtract, couldn't I? Right? I could even just do something like this. If I subtract those, 2x squared minus x squared is x squared. xy minus xy is 0. They cancel. 2 minus -2 is what? 2 minus -2? 4. There we go. So then x is equal to what? Plus or minus 2. And again, we would just need to check both of those. So if we check x equals 2, we could plug that into either equation. What if we plug it into the bottom equation? So if I plug x equals 2 into that one, I would just get 4 plus 2y equals -2. And if I solve that, I'm going to subtract 4 from both sides. So 2y equals negative 6. Everybody agree y equals negative 3? So I get the ordered pair x equals 2, y equals negative 3. If I pick the other one, if I pick x equals negative 2 and plug into this equation, I get 4 minus 2y equals negative 2, right? Subtract 4 from both sides. Negative 2y equals negative 6. So y equals 3. So my other ordered pair is going to be negative 2, positive 3. Everybody agree? Everybody good with that? And this is a weird looking one. If I look at the graph of this, these are, we've never really graphed functions like this before. That's what we get. They look kind of weird, but if we look for the points of intersection, there they are. We found them. Okay? Put those on our notes. Okay, last one. What about this guy? Substitution or elimination? I'd do elimination, don't you think? Which term would we want to eliminate? X squareds, yeah. So let's do, how about if we multiply the top one by negative 1, and the bottom one we leave alone. So that's going to give me negative x squared minus y squared equals negative 4. And on the bottom, I get x squared plus y minus 1 quantity squared equals positive 1. When I add those up, sure enough, the x squared terms cancel. And I'm just going to get, what am I going to be left with? I'm going to have y minus 1 quantity squared plus y squared equals negative 4 plus 1 is negative 3. Okay, good. All right, we can expand this out. This is good practice. What is y minus 1 quantity squared? Everybody take a second, digest that, and be ready to help me out. Y minus 1 quantity squared. What's that going to look like? What do you think, Ashton? What's y minus 1 quantity squared?
Y squared.
Good.
Minus 1y.
Minus,
Well, just minus y.
but it's 2ab, so 2y, there you go. 2y plus 1, good. Plus y, oh, was that supposed to be a plus or a minus? Supposed to be a minus, wasn't it? Whoops, that was my mistake. Let's fix that. That was supposed to be a minus, right? Because I'm doing negative y squared plus the quantity y minus 1 squared. Okay, equals negative 3. Now look what happened there, something good. The y squareds those y squareds canceled. Okay, good. We don't even get we end up with a simple linear equation. Negative 2y plus 1 equals negative 3. Subtract 1 from each side. Negative 2y equals negative 4, so y equals 2. I could plug that into either equation. Let's pick the top one, how about? If y equals 2, plug it in there, and we get x squared plus 2 squared equals 4. So what's my solution? What's x equal to? 0. Yeah, I get x squared equals 0. So x equals 0. So I only get a single ordered pair this time. I just get the ordered pair 0, 2. Okay, that's kind of strange. How could we get a single ordered pair? Well, we could. What's the top equation if I graph it? X squared plus y squared equals 4. You've seen stuff like that before, I think. I'll give you a hint. X squared plus y squared equals 2 squared. Not a triangle. It's a circle of radius 2. Okay? How about the bottom one? That's going to be, think about your translations. That's going to be a circle of radius 1, but it's slid in the y direction. It's slid up by 1. Okay? Does that make sense? Can you kind of see that a little bit? I mean, that's not stuff we ever did, but so it looks like that. So there is only a single point of intersection right there. Okay? Make sense? That's what the graphs look like, but we found it algebraically. All right, you can work, if there's any time left,